2.6, draw scatter plots and best fitting lines. So this is just a cute little comic illustration of a scatter plot, so that's why I put it in.
Okay, so here's 3 different scatter plots, and by looking at these, we can see the correlation between the x and y coordinates that are graphed.
Let's start with B, because that one's pretty clear that
it has a positive slope, therefore we call that a positive correlation between the x and the y coordinates.
it would follow that this might be a negative correlation.
Right.
And when you can't really tell what's going on, it just has no correlation at all.
So the positive correlation means as the x values get bigger, the y values increase as well. And a negative correlation means as the x values get bigger, the y values actually decrease.
The correlation coefficient we denote by R, and what is that?
It's a number from -1 to 1.
A number between -1 and 1. So I'm going to put right here, -1 is less than R, which is less than 1. Is it inclusive?
Yes.
Right.
It measures how well a line fits a set of data pairs. Now, if it is an R value near 1, then it's a positive slope, and it would be a good fit for the data pairs that you've graphed. If it's near -1, it's just as good a fit, but now it's a negative slope.
Okay, so if it is exactly 1,
then all the points lie on a line y equals mx plus b.
so if it's exactly 1 or exactly -1, that means it's a perfect fit. This would indicate a positive slope. This would indicate a negative slope. What do you think that near 0, which is in the middle of -1 and 1, is going to indicate?
That there's no correlation between the set of data pairs and an actual line.
Okay. A best fitting line can be found if that R is near the +1 or the -1.
And that would be the line that lies as close as possible to all the data points.
And so by that we're saying if we have data points that don't lie exactly on a line, then we want to have some above, we want to have some below, and we want that to pretty much be leveled out so that would make our best fitting line. So describe the correlation shown. Here we clearly have a positive correlation. And in this figure, we clearly have a negative correlation. And to find that line of best fit, it would be pretty easy. In this one, it would look something like that. In this one, I have to be careful that when I actually draw some lines in, that I'm thinking, I want some points below and I want some points above. I'm not saying that what I drew right now is the line of best fit. We're going to find how to do that on our calculator, actually. Tell whether the correlation coefficient for the data is closest to 1, -0.5, 0, 0.5, or 1. So, oops, and I meant to put a -1 here, so please fix that on your PowerPoint. This, again, would be an exact negative slope. This would be an exact positive slope. The 0 would be no correlation at all. And then the 0.5 would be some positive correlation. The -0.5 would be some negative correlation. In this first, we note that it is looking like it has some negative correlation here, but it's not -1 by any means. So that's probably going to be closest to -0.5. Wouldn't you say?
Absolutely.
This one, I cannot tell what's going on at all. So I'm going to say the correlation is 0. And then this one, it looks pretty close to a line, that data. So I'm going to say that it's close to 1. It's not exactly 1. It is close to 1. So to approximate a best fitting line, if you have to do this by hand, you would sketch the line, as I kind of tried to do in the diagram. Sketch the line that appears to follow most closely the trend line given by the data points. There should be about as many points above the line as below it. Then you would just choose 2 points on that line, estimate the coordinates of that point, and then get the slope from there. You have a point and find the equation of the line. Usually in this class, be doing this more accurately with our graphing calculator since we have it. So let's do that in this example here.
Okay, the following table shows data collected in an AP statistics class to see if there was a correlation between the number of hours spent studying and the scores on the exam. So we're going to approximate the best fitting line first, and we're going to do this using our calculator.
And first of all, do you see a positive correlation here?
I do.
So in this AP statistics class, they did show that more hours spent studying correlated to a higher test score. That's what we use statistics for. All right, so let's use our calculator. In order to do this, we need to enter all of our data. We enter it into the stat plot. So we click the stat key. I'm highly suggesting that you take some notes on what I'm doing as I'm doing it. So I hit the stat key and I want to edit. If when you go here, you already have some data, let me put some fake data in. If you already had some, you're going to go up to L1. You're going to highlight it by pressing the up arrow. Then you're going to hit clear, enter, and it will delete everything that's there. All right, so now that I have some deleted lists, I'm going to go ahead and just put in this data. And then in L2, the other. You know what? I'm going to purposely leave out 68 right now so that I can show you how to insert something if you mess up. So now I know I've screwed up because they aren't even right there. I have one less data point in L2, and I purposely left out the 68 right here. So in order to fix that, what I would do is I would hit second insert, and that will give me an extra space so that I can fix it without having to go and fix everything. Again, I press second and the delete key, which gives you insert. And so I needed to put a 68 there. All right, now all of my data is in. And so to graph this, I would go zoom, and then there's this nice feature, the zoom 9 is zoom stat. I would zoom stat, but first actually I should turn off whatever I'm plotting. So I'm going to clear that one out and turn on my plot 1. So to do that, again, I just press the up arrow until it's highlighting plot 1. I press enter on that, so now it's highlighted, and then you could do the zoom 9. And you see that I have my data points plotted like I have here. In order to find the best fitting line, I do lin reg. To get that, I go back to stat. Remember, I pressed edit in order to put in my data. Now I'm going to go over to calc, and I'm going to do lin reg. It's of the form ax plus b, which is a line. Press enter to put this into y1. I hit the vars key. I go over to y-vars. I click function. Enter. I want to pick y1. I want to put it in y1. Press enter again. Here I have y equals 6.7668x plus 59.0257. That would be the equation of my line. And look at this. Because I put that y1 there, it automatically went in. Let's graph it. Looks like a pretty good line of fit, doesn't it?
Beautiful.
All right. Now, I expect all of you to have detailed notes on your page about that process that I just went through. You know, even how I got to vars and went over to y-vars. Might be nice for you to write to yourself, this is how I take notes sometimes. We went to vars, and since it's a key, a lot of times I box it. And then we went over to y-vars, so we went over to y-vars. And then we choose one function. And then we chose one y1. So that's how I take notes sometimes. You might want to take notes like that. So again, in part A, our line of best fit, and we can just do one decimal point here, was y equals
6.8x plus 59.
Plus 59. In part B, it says, if a student spent 5 hours studying, predict what score he or she would earn. Well, that's going to just be y after 5 hours when x is 5. And I actually want to do this on my calculator. And so let me show you how I would do that. I would go back to my home screen, and to do that I press second quit. So I'm back at my home screen. I'm just going to clear it. And I want to do y1 of 5. Again, this y equals was in y1. So I'm going to go to vars. Again, go over to the y-vars. Do function y1 of 5. Just like that, just like I wrote on my paper. And it's going to pop out my answer. And let's just try it to make sure we got it right. 6.8 times 5 plus 59. This is going to be approximate. Yep, that's about right. So the score that they're going to get is about a 93%. Okay, so the lesson there should be, spend more time studying, you will get a better score. And that's it for this lesson.